Hi, this is Sleeper, and we are continuing with our bug bounty hunter job role path from Hack the Box and the Introduction to Web Applications module with the front-end components HTML. The first and most dominant component of the front end of web applications is HTML, Hypertext Markup Language. HTML is at the very core of any web page we see on the internet. It contains each page's basic elements, including titles, forms, images, and many other elements. The web browser, in turn, interprets these elements and displays them to the end user. The following is a very basic example of HTML page. So we have a page title, heading, paragraph. This would display the following. As we can see, HTML elements are displayed in a tree form, similar to XML and other languages. HTML structure, document, HTML, head, title, body, H1 and P. Each element can contain other HTML elements, while the main HTML tag should contain all other elements within the page, which falls under document, distinguishing between HTML and documents written for other languages such as XML documents. The HTML elements of the above code can be viewed as follows. Each HTML element is opened and closed with a tag that specifies the element's type. Example, bracket P, or bracket greater greater than. I'm not sure what that symbol is called. So P for paragraphs, where the content would be placed between these tags. Tags may also hold the element's ID or classes. Example, the PID equals para1 or PID equals red paragraphs, which is needed for CSS to properly format the element. Both tags and the content comprise the entire element. URL encoding. An important concept to learn in HTML is URL encoding, or percent encoding. For a browser to properly display a page's contents, it has to know the character set, the char set, in use. In URLs, for example, browsers can only use ASCII encoding, which only allows alphanumerical characters and certain special characters. Therefore, all other characters outside of the ASCII character set have to be encoded within a URL. URL encoding replaces unsafe ASCII characters with a percent symbol, followed by 2 hexadecimal digits. For example, the single quote character is encoded to %27, which can be understood by browsers as a single quote. URLs cannot have spaces in them and will replace a space with either a plus sign or %20. Some common character encodings are as follows, and a full character encoding table can be found here. Many online tools can be used to perform URL encoding/decoding. Furthermore, the popular web proxy burp suite has a decoder/encoder which can be used to convert between various types of encodings. Try encoding, decoding some characters and strings using this online tool. Usage. The head element usually contains elements that are not directly printed on the page, like the page title, while all main page elements are located under body. Other important elements include the style, which holds the page's CSS code, and the script, which holds the JavaScript code on the page, as we will see in the next section. Each of these elements is called a DOM, a document object model. the World Wide Web Consortium, the W3C, defines DOM as the W3C Document Object Model, DOM, is a platform and language neutral interface that allows programs and scripts to dynamically access and update the content, structure, and style of a document. The DOM standard is separated into three parts: Core DOM, the standard model for all document types; XML DOM, the standard model for XML documents; and HTML DOM, the standard model for HTML documents. For example, from the above tree view, we can refer to DOMs as document, header, or document.h1, and so on. Understanding the HTML DOM structure can help us understand where each element we view on the page is located, which enables us to view the source code of a specific element on the page and look for potential issues. We can locate HTML elements by their ID, their tag name, or by their class name. This is also useful when we want to utilize front-end vulnerabilities like cross-site scripting to manipulate existing elements or create new elements to serve our needs. We have a question here. What is the HTML tag used to show an image? So let's see if we have that answer up here. So let's check a page out. It might be on here somewhere. Each of these elements. So let's check this out. We're looking for the HTML tag to show an image. So let's see if it's on here. Let's find image elements. We can also just Google it. So HTML image tag. Just go with the first option here, and that's pretty simple. Image. So let's hop back. There we go. And carrying on. Cascading Style Sheets, CSS. CSS, or Cascading Style Sheets, is the style sheet language used alongside HTML to format and set the style of HTML elements. Like HTML, there are several versions of CSS, and each subsequent version introduces a new set of capabilities that can be used for formatting HTML elements. Browsers are updated alongside it to support these new features. Example: at a fundamental level, CSS is used to define the style of each class or type of HTML elements, for example body or h1, such that any element within that page would be represented as defined in the CSS file. This could include the font family, font size, background color, text color, and alignment, and more. Here's an example. As previously mentioned, this is why we may set unique IDs or class names for certain HTML elements so that we can later refer to them within CSS or JavaScript when needed. Syntax: CSS defines the style of each HTML element or class between curly brackets, within which the properties are defined with their values. For example, element property : value. Each HTML element has many properties that can be set through CSS, such as height, position, border, margin, padding, color, text align, font size, and hundreds of other properties. All of these can be combined and used to design visually appealing websites. web pages. CSS can be used for advanced animations for a wide variety of uses, from moving items all the way to advanced 3D animations. Many CSS properties are available for animations like at keyframes, animation, animation duration, animation direction, and many others. You can read more and try out many of these animation properties here. Usage. CSS is often used alongside JavaScript to make quick calculations, dynamically adjust the style properties of certain HTML elements, or achieve advanced animations based on keystrokes or the mouse cursor location. The following example beautifully illustrates such capabilities of CSS when used with HTML and JavaScript. Parallax Depth Cards by Andy Merskin on CodePen. Very nice. You can click on the tabs on the top left to view the source code. Very nice. So here's the styling, and that will, so the JavaScript, the interactive elements. This shows that even HTML and CSS are among the most basic cornerstones of web development when properly used. They can be used to build visually stunning web pages, which can make interacting with web applications a much easier and more user-friendly experience. Furthermore, CSS can be used alongside other languages to implement their styles, like XML or within SVG items, and can also be used in modern mobile development platforms to design entire mobile application user interfaces. Frameworks. Many may consider CSS to be difficult to develop. In contrast, others may argue that it is inefficient to manually set the style and design all of HTML elements in each web page. This is why many CSS frameworks have been introduced, which contain a collection of CSS style sheets and designs to make it much faster and easier to create beautiful HTML elements. Furthermore, these frameworks are optimized for web application usage. They are designed to be used with JavaScript and for wide use within a web application, and contain elements usually required within modern web applications. Some of the most common CSS frameworks are Bootstrap, SAS, CASS, Foundation, Bulma, and Pure. So here's a question. What is the CSS property value used to make an HTML element's text aligned to the left? So let's see if there is a source that it most likely position, or oh, here we go, text align. So let's see if this is our answer. Property, or maybe text align left, maybe in quotes. Property value. Okay, so let's just Google search this. Text align CSS. Text align left. We were close. Let's see. Let's just see our first option here. Text align colon. Okay, so colon, semicolon. Let's try it. Colon, semicolon. There we go. So that's the right format. And carrying on. JavaScript. JavaScript is one of the most used languages in the world. It is mostly used for web development and mobile development. JavaScript is usually used on the front end of an application to be executed within a browser. Still, there are implementations of backend JavaScript used to develop entire web applications, like Node JavaScript. While HTML and CSS are mainly in charge of how a web page looks, JavaScript is usually used to control any functionality that the front-end web application requires. Without JavaScript, a web page would be mostly static and would not have much functionality or interactive elements. Example, within the page source code, JavaScript code is loaded with the script tag as follows. A web page can also load remote JavaScript with source and the script's link as follows. An example of basic use of JavaScript within a web page is the following. The above example changes the content of the button 1 HTML element. From here on, there are many more advanced uses of JavaScript on a web page. The following shows an example of what the above JavaScript code would do when linked to a button click. As with HTML, there are many sites available online to experiment with JavaScript. One is JS Fiddle, which can be used to test JavaScript, CSS, and HTML, and save code snippets. JavaScript is an advanced language, and its syntax is not as simple as HTML or CSS. Usage. Most common web applications heavily rely on JavaScript to drive all needed functionality on the web page, like updating the web page, view in real time, dynamically updating content in real time, accepting and processing user input, and many other potential functionalities. JavaScript is also used to automate complex processes and perform HTTP requests to interact with the back-end components and send and retrieve data through technologies like AJAX. In addition to automation, JavaScript is also used alongside CSS, as previously mentioned, to drive advanced animations that would not be possible with CSS alone. Whenever we visit an interactive and dynamic web page that uses many advanced and visually appealing animations, we are seeing the result of active JavaScript code running on our browser. All modern web browsers are equipped with JavaScript engines that can execute JavaScript code on the client side without relying on the back-end web server to update the page. This makes our using JavaScript a very fast way to achieve a large number of processes quickly. Frameworks. As web applications become more advanced, it may be inefficient to use pure JavaScript to develop an entire web application from scratch. This is why a host of JavaScript frameworks have been introduced to improve the experience of web application development. These platforms introduce libraries that make it very simple to recreate advanced functionalities like user login and user registration, and they introduce new technologies based on existing ones, like the use of dynamically changing HTML code instead of static HTML code. These platforms either use JavaScript as their programming language or use an implementation of JavaScript that compiles its code into JavaScript code. Some of the most common front-end JavaScript frameworks are Angular, React, Vue, and jQuery. A list of and comparison of common JavaScript frameworks can be found here. Moving on to our front-end vulnerabilities, starting with sensitive data exposure. All of the front-end components we covered are interacted with on the client side. Therefore, if they are attacked, they do not pose a direct threat to the core back end of the web application, and usually will not lead to permanent damage. However, as these components are executed on the client side, they put the end user in danger of being attacked and exploited if they do have any vulnerabilities. If a front-end vulnerability is leveraged to attack admin users, it could result in unauthorized access to sensitive data, service disruption, and more. Although the majority of web application penetration testing is focused on back-end components and their functionality, it is important also to test front-end components for potential vulnerabilities, as these types of vulnerabilities can sometimes be utilized to gain access to sensitive functionality, for example, an admin panel, which may lead to compromising the entire server. Sensitive data exposure refers to the availability of sensitive data in clear text to the end user. This is usually found in the source code of the web page or page source on the front end of web applications. This is the HTML source code of the application, not to be confused with the back-end code that is typically only accessible on the server itself. We can view any website's page source in our browser by right-clicking anywhere on the page and selecting View Page Source from the pop-up menu. Sometimes a developer may disable right-clicking on a web application, but this does not prevent us from viewing the page source, as we can merely type Ctrl-U or view the page source through a web proxy, such as Burp Suite. Let's take a look at the Google page source, google.com. Right-click and choose View Page Source, and a new tab will open in our browser with the URL View Source, google.com. Here we can see the HTML, JavaScript, and external links. Take a moment to browse the page source a bit. So we'll do that. Go to Google, right-click, View Page Source. Just take a look briefly for a moment. It's kind of messy. Very messy. But it goes on. Goes on for a while. There's probably just one line that's super long. Sometimes we may find login credentials, hashes, or other sensitive data hidden in the comments of a web page's source code or within external JavaScript code being imported. Other sensitive information may include exposed links or directories, or even exposed user information, all of which can be potentially leveraged to further our access within the web application or even the web application's supporting infrastructure, like the web server, database servers, etc. For this reason, one of the first things we should do when assessing a web application is to review its page source code to see if we can identify any low-hanging fruit, such as exposed credentials or hidden links. Example: at first glance, this login form does not look like anything out of the ordinary. Let's take a look at the page source. We see that the developers added some comments that they forgot to remove, which contain test credentials. To do: remove test credentials. Test. The comment seems to be a reminder for the developers to remove the test credentials. Given that the comment has not been removed yet, these credentials may still be valid. Although it is not very common to find login credentials in developer comments, we can still find various bits of sensitive and valuable information when looking at the source code, such as test pages or directories, debugging parameters, or hidden functionality. There are various automated tools that we can use to scan and analyze available page source code to identify potential paths or directories and other sensitive information. Leveraging these types of information can give us further access to the web application, which may help us attack the backend components to gain control over the server. Prevention. Ideally, the front-end source code should only contain the code necessary to run all of the web application's functions, without any extra code or comments that are not necessary for the web application to function properly. It is always important to review the code that will be visible to the end users through the page source or run it through tools to check for exposed information. It is also important to classify data types within the source code and apply controls on what can or cannot be exposed on client side. Developers should also review client-side code to ensure that no unnecessary comments or hidden links are left behind. Furthermore, front-end developers may want to use JavaScript code packing or obfuscation to reduce the chances of exposing sensitive data through JavaScript code. These techniques may prevent automated tools from locating these types of data. So we'll start our instance and we'll take a look at the question below. We'll spawn our target. Check the above login form for exposed passwords. Submit the password as the answer. So most likely we will take a look at the source code. I'll just load it up here. Should be pretty quick. View page source and taking a look. Here we go. Same thing. So I'll copy that and paste that in. HTML injection. Another major aspect of front-end security is validating and sanitizing accepted user input. In many cases, user input validation and sanitization is carried out on the back end. However, some user input would never make it to the back end in some cases and is completely processed and rendered on the front end. Therefore, it is critical to validate and sanitize user input on both the front end and the back end. HTML injection occurs when unfiltered user input is displayed on the page. This can either be through retrieving previously submitted code, like retrieving a user comment from the back-end database, or by directly displaying unfiltered user input through JavaScript on the front end. When a user has complete control of how their input will be displayed, they can submit HTML code and the browser may display it as part of the page. This may also include a malicious HTML code like an external login form, which can be used to trick users into logging in while actually sending their login credentials to a malicious server to be collected for other attacks. Another example of HTML injection is web page defacing. This consists of injecting new HTML code to change the web page's appearance, inserting malicious ads, or even completely changing the page. This type of attack can result in severe reputational damage to the company hosting the web application. Example. The following example is a very basic web page with a single button. Click to enter your name. When we click on the button, it prompts us to input our name and then displays our name as your name is ... If no input sanitization is in place, this is potentially an easy target for HTML injection and cross-site scripting attacks. We take a look at the page source code and see no input sanitization in place whatsoever, as the page takes user input and directly displays it. To test for HTML injection, we can simply input a small snippet of HTML code as our name and see if it is displayed as part of the page. We will test the following code, which changes the background image of the web page. Once we input it, we see that the web page's background image changes instantly. In this example, as everything is being carried out on the front end, refreshing the web page would reset everything back to normal. So we have another question. What text would be displayed on the page if we were to use the following payload as our input? So we'll copy this payload. I guess first we got to grab our IP address and go to the website. Click to enter your name. Our name is going to be our payload. Oops. And OK. Your name is click me. What text would be displayed on the page? Well, it says your name is click me, so we'll try this and we'll see what happens when we click on it. Hackthebox.com. Oh no. So there we go. Carrying on. Cross-site scripting XSS. HTML injection vulnerabilities can often be utilized to also perform cross-site scripting XSS attacks by injecting JavaScript code to be executed on the client side. Once we can execute code on the victim's machine, we can potentially gain access to the victim's account or even their machine. Cross-site scripting is very similar to HTML injection in practice. However, cross-site scripting involves the injection of JavaScript code to perform more advanced attacks on the client side instead of merely injecting HTML code. There are three main types of cross-site scripting. Reflected cross-site scripting occurs when user input is displayed on the page after processing, for example, search result or error message. Stored cross-site scripting occurs when user input is stored in the back-end database and then displayed upon retrieval, for example, posts or comments. And DOM cross-site scripting occurs when user input is directly shown in the browser and is written to an HTML DOM object, for example, vulnerable username or page title. In the example we saw for HTML injection, there was no input sanitization whatsoever. Therefore, it may be possible for the same page to be vulnerable to cross-site scripting attacks. We can try to inject the DOM cross-site scripting JavaScript code as a payload, which should show us the cookie value for the current user. Once we input our payload and hit OK, we see that an alert pops up with the cookie value in it. This payload is accessing the HTML document tree and retrieving the cookie object's value. When the browser processes our input, it will be considered a new DOM and our JavaScript will be executed, displaying the cookie value back to us in a pop-up. An attacker can leverage this to steal cookie sessions and send them to themselves and attempt to use the cookie value to authenticate to the victim's account. The same attack can be used to perform various types of other attacks against a web application's users. Cross-site scripting is a vast topic that will be covered in depth in later modules. Question: try to use cross-site scripting to get the cookie value in the page above. So we'll grab the same JavaScript code and paste that in. Hit OK. Cookie. Cross-site scripting is fun. Sure is. It wants just the cookie. There we go. And the last of the front-end vulnerabilities here, cross-site request forgery, CSRF. The third type it's saying, the third type of front-end vulnerability that is caused by unfiltered user input is cross-site request forgery, CSRF. CSRF attacks may utilize cross-site scripting vulnerabilities to perform certain queries and API calls on a web application that the victim is currently authenticated to. This would allow the attacker to perform actions as the authenticated user. It may also utilize other vulnerabilities to perform the same functions, like utilizing HTTP parameters for attacks. A common CSRF attack to gain higher privilege access to a web application is to craft a JavaScript payload that automatically changes the victim's password to the value set by the attacker. Once the victim views the payload on the vulnerable page, example, malicious comment containing the JavaScript CSRF payload, the JavaScript code would execute automatically. It would use the victim's logged in session to change their password. Once that is done, the attacker can log into the victim's account and control it. CSRF can also be leveraged to attack admins and gain access to their accounts. Admins usually have access to sensitive functions, which can sometimes be used to attack and gain control over the backend server, depending on the functionality provided to admins within a given web application. Following this example, instead of using JavaScript code that would return the session cookie, we would load a JavaScript file as follows. The exploit.javascript file would contain the malicious JavaScript code that changes the user's password. Developing the exploit.js in this case requires knowledge of this web application's password changing procedure and APIs. The attacker would need to create JavaScript code that would replicate the desired functionality and automatically carry it out. For example, the JavaScript code that changes our password for this specific web application. Prevention. Though there should be measures on the back end to detect and filter user input, it is also always important to filter and sanitize user input on the front end before it reaches the back end, and especially if this code may be displayed directly on the client side without communicating with the back end. Two main controls must be applied when accepting user input: sanitization and validation. So sanitization is removing special characters and non-standard characters from user input before displaying it or storing it. Validation is ensuring that the submitted user input matches the expected format. For example, submitted email matched email format. Furthermore, it is also important to sanitize displayed output and clear any special / non-standard characters. In case any attacker manages to bypass front-end and back-end sanitization and validation filters, it will still not cause any harm on the front end. Once we sanitize and or validate user input and displayed output, we should be able to prevent attacks like HTML injection, cross-site scripting, or cross-site request forgery. Another solution would be to implement a web application firewall, which should help to prevent injection attempts automatically. However, it should be noted that web application solutions can be potentially bypassed, so developers should follow coding best practices and not merely rely on an appliance to detect/block attacks. As for cross-site request forgery, many modern browsers have built-in anti-CSRF measures which prevent automatically executing JavaScript code. Furthermore, many modern web applications have anti-CSRF measures, including certain HTTP headers and flags that can prevent automated requests. For example, anti-CSRF token or HTTP only XSS protection. Certain other measures can be taken from a functional level, like requiring the user to input their password before changing it. Many of these security measures can be bypassed, and therefore these types of vulnerabilities can still pose a major threat to the users of a web application. This is why these precautions should only be relied upon as a secondary measure, and developers should always ensure that their code is not vulnerable to any of these attacks. This cross-site request forgery prevention cheat sheet from OWASP discusses the attack and prevention measures in greater detail. Moving on to our back-end components and back-end vulnerabilities. So back-end servers. A back-end server is the hardware and operating system on the back end that hosts all of the applications necessary to run the web application. It is the real system running all the processes and carrying out all of the tasks that make up the entire web application. The back-end server would fit in the data access layer. Software. The back-end server contains the three other back-end components, so web server, database, and development framework. Other software components on the back end may include hypervisors, containers, and web application firewalls. There are many popular combinations of stacks for back-end servers, which contain a specific set of back-end components. Some common examples include LAMP, Linux Apache MySQL PHP, WAMP, Windows Apache MySQL PHP, WINS, Windows ISS.NET and SQL Server, AMP, macOS Apache MySQL and PHP, and XAMPP, cross-platform Apache MySQL and PHP/Perl. There's a comprehensive list of web solution stacks in this article here. Hardware. The backend server contains all of the necessary hardware. The power and performance capabilities of this hardware determine how stable and responsive the web application will be. As previously discussed in the architecture section, many architectures, especially for huge web applications, are designed to distribute their load over many backend servers that collectively work together to perform the same tasks and deliver the web application to the end user. Web applications do not have to run directly on a single backend server, but may utilize data centers and cloud hosting services that provide virtual hosts for the web application. So what operating system is WAMP? If we remember that from above, Windows. Web servers. A web server is an application that runs on the back-end server which handles all of the HTTP traffic from the client-side browser, routes it to the requested pages, and finally responds to the client-side browser. Web servers usually run on TCP ports 80 or 443 and are responsible for connecting end users to various parts of the web application in addition to handling their various responses. Workflow. A typical web server accepts HTTP requests from the client side and responds with different HTTP responses and codes, like a code 200 OK response for a successful request, a code 404 not found when requesting pages that do not exist, code 403 forbidden for requesting access to restricted pages, and so on. The following are the most common HTTP response codes. 200 OK, request has succeeded. 301, move permanently. 302, found. And you can check out that list there. Web servers also accept various types of user input within HTTP requests, including text, JSON, and even binary data. For example, file uploads. Once a web server receives a web request, it is then responsible for routing it to its destination, run any processes needed for that request, and return the response to the user on the client side. The pages in the files that the web server processes and routes traffic to are the web application core files. The following shows an example of requesting a page in a Linux terminal using the curl utility and receiving the server response while using the -i flag, which displays the headers. Well, this curl command example shows us the source code of the web page. Many web server types can be utilized to run web applications. Most of these can handle all types of complex HTTP requests, and they are usually free of charge. We can even develop our own basic web server using languages such as Python, JavaScript, and PHP. However, for each language, there's a popular web application that is optimized for handling large amounts of web traffic, which saves us time in creating our own web server. Apache. Apache, or HTTPD, is the most common web server on the internet, hosting more than 40% of all internet websites. Apache usually comes pre-installed in most Linux distributions and can also be installed on Windows and Mac OS servers. Apache is usually used with PHP for web application development, but it also supports other languages like .NET, Python, Perl, and even operating system languages like Bash through CGI. Users can install a wide variety of Apache modules to extend its functionality and support more languages. For example, to support server PHP files, users must install PHP on the backend server, in addition to installing the mod_PHP module for Apache. Apache is an open source project, and community users can access its source code to fix issues and look for vulnerabilities. It is well maintained and regularly patched against vulnerabilities to keep it safe against exploitation. Furthermore, it is very well documented, making using and configuring different parts of the web server relatively easy. Apache is commonly used by startups and smaller companies as it is straightforward to develop for. Still, some big companies utilize Apache, including Apple, Adobe, Baidu. Nginx. Nginx is the second most common web server on the internet, hosting roughly 30% of all internet websites. Nginx focuses on serving many concurrent web requests with relatively low memory and CPU load by utilizing an async architecture to do so. This makes Nginx a very reliable web server for popular web applications and top businesses worldwide, which is why it is the most popular web server among high traffic websites, with around 60,000 of the top 100,000 websites using Nginx. Nginx is also free and open source, which gives all the same benefits previously mentioned, like security and reliability. Some popular websites that utilize Nginx include Google, Facebook, Twitter, Cisco, Intel, Netflix, and Hack the Box. And ISS, Microsoft ISS, Internet Information Services, is the third most common web server on the internet, hosting around 15% of all internet websites. ISS is developed and maintained by Microsoft and mainly runs on Microsoft Windows servers. ISS is usually used to host web applications developed for the Microsoft .NET framework, but can also be used to host web applications developed in other languages like PHP, or host other types of services like FTP. Furthermore, IIS is very well optimized for Active Directory integration and includes features like Windows Auth for authenticating users using Active Directory, allowing them to automatically sign in to web applications. Though not the most popular web server, many big organizations use IIS as their web server. Many of them use Windows Server on the back end or rely heavily on Active Directory within their organization. Some popular websites that utilize IIS include Microsoft, Office 365, Skype, Stack Overflow, and Dell. Aside from these three web servers, there are many other commonly used web servers like Apache Tomcat for Java web applications and Node.js for web applications developed using JavaScript on the back end. If a web server returns a HTTP code 201, what does that stand for? If we search that on our page, 201, was that on this page? It was on the previous page, I believe. No, it's here. 201, not on our list. We'll have to check out. Let's see if there's a list here. Successful responses. 201. So our 201 HTTP code, the request succeeded, and a new resource was created as a result. This is typically the response sent after post requests or some put requests. So we can say created, most likely, in capitals, starting with a capital C. There we go. Alright, databases. Web applications utilize backend databases to store various content and information related to the web application. This can be core web application assets like images and files, web application content like posts and updates, or user data like usernames and passwords. This allows web applications to easily and quickly store and retrieve data to enable dynamic content that is different for each user. There are many different types of databases, each of which fits a certain type of use. Most developers look for certain characteristics in a database, such as speed in storing and retrieving data, size when storing large amounts of data, and scalability as the web application grows, and cost. Relational SQL. So a relational SQL database stores their data in tables, rows, and columns. Each table can have unique keys which can link tables together and create relationships between tables. For example, we have a users table and a relational database containing columns like ID, username, first name, last name, and so on. The ID can be used as the table key. Another table, posts, may contain posts made by all users, with columns like ID, user ID, date, content, and so on. We can link the ID from the users table to the user ID in the posts table to easily retrieve the user details for each post without having to store all user details with each post. A table can have more than one key, as another column can be used as a key to link with another table. For example, the ID column can be used as a key to link the posts table to another table containing comments, each of which belongs to a certain post, and so on. The relationship between tables within a database is called a schema. This way, by using relational databases, it becomes very quick and easy to retrieve all data. about a certain element from all databases. For example, we can retrieve all details linked to a certain user from all tables within a single query. This makes relational databases very fast and reliable for big data sets that have a clear structure and design. Databases also make data management very efficient. Some of the most common relational databases include MySQL. This is the most commonly used database around the internet. It is an open source database and can be used freely, free of charge. MS SQL, this is Microsoft's implementation of relational database, widely used on Windows servers and IIS. Oracle, a very reliable database for big businesses, and is frequently updated with innovative database solutions to make it faster and more reliable. It can be costly, even for big businesses. And the PostgreSQL, another free and open source relational database. It is designed to be easily extensible, enabling adding advanced new features without needing a major change to the initial database design. Other common SQL databases include SQLite, Maria Database, Amazon Aurora, and Azure SQL. Non-relational NoSQL. A non-relational database does not use tables, rows, columns, primary keys, relationships, or schemas. Instead, a NoSQL database stores data using various storage models, depending on the type of data stored. Due to the lack of a defined structure for the database, NoSQL databases are very scalable and flexible. When dealing with datasets, they are not very well defined and structured. A NoSQL database would be the best choice for storing our data. There are 4 common storage models for NoSQL databases: key value, document-based, wide column, and graph. Each of the above models has a different way of storing data. For example, the key value model usually stores data in JSON or XML and has a key for each pair, storing all of its data as its value. The above example can be represented using JSON as follows. It looks similar to a dictionary / map or key value pair in languages like Python or PHP, for example, key and value, where the key is usually a string and the value can be a string, dictionary, or any class object. The document-based model stores data in complex JSON objects, and each object has certain metadata, while storing the rest of the data similarly to the key value model. Some of the most common NoSQL databases include MongoDB. This is the most common one. It is free and open source. It uses the document-based model and stores in JSON objects. Elasticsearch, another free and open source NoSQL database, optimized for storing and analyzing huge datasets. As its name suggests, searching for data within this database is very fast and efficient. And Apache Cassandra, also free and open source, is very scalable and is optimized for gracefully handling faulty values. Other common NoSQL databases include Redis, Neo4j, CouchDB, and Amazon DynamoDB. So use and web applications. Most modern web development language and frameworks make it easy to integrate, store, and retrieve data from various data types. But first, the database has to be installed and set up on the back-end server. And once it's up and running, the web applications can start utilizing it to store and retrieve data. For example, within a PHP web application, once MySQL is up and running, we can connect to the database server with this code. Then we can create a new database with the following. After that, we can connect our new database and start using the MySQL database through MySQL syntax right within PHP as follows. Web applications usually use user input when retrieving data. For example, when a user uses the search function to search for other users, their search input is passed to the web application, which uses the input to search within the database. Finally, the web application sends the result back to the user. This basic example shows us how easy it is to utilize databases. However, if not securely coded, database code can lead to a variety of issues like SQL injection vulnerabilities. So it's asking, what type of database is Google's Firebase database? So we can check and see if it's on our list. We got 2 chances. Let's guess a SQL. Okay, let's go with NoSQL. And it's a NoSQL. So taking a look here, what we got left, and taking a look at our time. So we're at an hour. In our third portion, our third part, we'll finish this up with development frameworks and APIs and our backend vulnerabilities. So once again, my name is Sleeper, and until next time.